sketching it. So the manhole, a lot of people weren't here in lecture 1. I probably shouldn't be telling you this, but I'm in a good mood because it's a Friday, so we know that, we're given that distance to the bottom of the manhole is 100, and the thickness of the walls of the manhole, let's make them 100 as well. In reality, they're precast panels, and precast concrete panels are normally 90. They're pre-stressed, precast, and they tend to have manholes. They'll put the bottom one in, then they sort of fit into the next one. So the next one fits on top, so on and so on, and until you get to the top. So they have different thicknesses, but they're all the same diameter. The internal diameter of your average manhole is 1050. Of course, it'll have a lid on top, and the manhole lid is 600 millimeters diameter. Oh, mate, it's funny, in civil engineering we talk about everything in meters, and suddenly we call a lid 600 millimeter diameter. Sounds a bit weird. Should be 0.6, shouldn't it? But that's just Kiwiisms, I suppose. The other side is the side that is in question. Now, we can draw the pipe. We know that because we can work that out using the same maths over there. We need to come back 100 and we draw in the outlet structure. In fact, the outlet structure looks like that. Why does it look like that? Because in plan view, it's going to look like this. That distance is 1 meter. That distance is 1 meter. That angle is 45 degrees. And that distance there is 900. So when you're looking at it front on, it looks like this. Get out of the way, I'll start drawing from this side. The pipe is 100 off the apron. That is what we call the apron. These are called wing walls. And this is called the head wall, if you want to be precise. That is sticking out by 100. So everything's kind of sticking out by 100, and that drop there is 100 as well. So I've got the drop there. That distance there is a pipe diameter, and that distance across there is a pipe diameter. So it's going to be 300, 300, 300, which is your 900, all right? So that width is going to be equal to that width. So I suggest you draw it in plan view first. It's a bit wonky there. It should be in plan view, it should look like that. Now this height here, we can't determine that height until we've drawn the ground line on. So we'll determine that today. that distance is 100 millimeters above ground line. And what we're going to find today is that that height is going to be around about 1 meter, maybe more. And any concrete structure that is 1 meter or more has to be signed off by a structural engineer, which means you need to bring that to the attention of the structural engineer, either in your office or a contractor who's working for you. Okay, I don't know why it's 1 meter. I think possibly a small child it could crush, or a small person, but generally the meter is the rule for anything that's structural. Okay, so obviously they'll need to design a footing for it, they'll need to design the height of it, and they'll need to design how much reinforcing is in it. The smaller if you go to the website of a pipe website like Hines, Windstones, they'll have tiny little head walls that are standards, but you see that doesn't work here because it's coming in quite low in the wetlands, and we've got quite a high ground profile, right? So I'm going to draw up the pipe, the platform. If we've got a wee bit of time, I might give you a bit of an example of how you work through these things here, but generally I let you draw them on yourself. This here takes care of itself once you've got your ground line. You'll see it's quite deep. It's quite a deep manhole. And all these levels are quite critical at putting on with little triangles on your drawing. A lot of students just think they'll draw it and that's it, but the contractors need to know those levels, and the level on that outlet will determine what the structural engineer comes up with for a design.